Okay, so last time we saw something about data imputation, right? How to manipulate or change the data values that are missing in place. Okay, so sorry. Okay, so we'll start with data normalization today. So anybody can guess what is data normalization? Why do we need? Anybody has any idea about normalization? Okay, then nobody has any clue. So data normalization is like you want to convert the data into the range of 0 to 1. Okay, so there are two methods here to convert the data or change the distribution. No, keeping the distribution constant and changing the range maximum and minimum value of that data set, right? So first one is normalization, and then second one is standardization. So in normalization, what you do, you just divide each and every value with first you find out the maximum value for a variable, right? So suppose your data is in between 1 to 15. Okay, so you have values like 1, 5, 7, 13, 15. Now say you want to normalize this data set, then you will divide each and every value with the maximum value. Okay, so maximum one in here will be like, yeah, say you have data from 1 to 15. So 15 will be your maximum value, and you will divide each and every value with 15. Okay, so that will give you a range of 0 to 1. Okay, and the distribution will be same. The values just will be computed in or transformed into another form. Okay, so for data normalization, we will first need to okay. For data normalization, you will need the sklearn library, and from that you will need pre-processing function. Okay. Now, before that, there is one more thing that you can do to import the dataset. You can either put your data or upload your data in this folder in which you have stored your Python files. Okay. And second, you can do Second, you can do is import the dataset directly from the library. Okay, so the Python has a few or number of data sets which you can use for your computation or anything, right? So for that, one of this data set is iris data set, so that you can import from these commands. Okay, we'll not see how to import this data set from library because it will take time, because the importation will need the download. The file will be downloaded in here. Okay, but you can see this. What you can do is run these commands on your own, and if you get any difficulty, we can discuss it tomorrow. Okay, so this is the command. First, you will need to import the dataset with this command, and the second one, you are assigning the dataset to a variable. Okay, so these are the two things that you will need. First one is first import the dataset from sklearn.datasets library, and then uh, whatever value data you have assigned, you need to assign it to imported whatever data you have imported from the library, that you need to assign to a variable. Okay, so in here we have used iris name for the variable. Now what I have done is I have downloaded the file already, and in Python programs I have this file data iris, right? So this is iris data set altogether. Okay, so I'll import this data set by this pd.read_csv command, and this will be the file name. This is in CSV format, so that will be data iris and .csv. Okay, so and once the data gets imported in here, we have assigned it to a variable df. Okay, and then first before this, you will need to import few libraries that we have learned in previous lectures also. Okay, so once you have imported the okay, once you have imported the data set, so we'll print the shape. So we have like okay, we'll see the data first five entries. So in this manner, you will get your data set. Okay, first there will be four columns, five columns. Okay, and from the shape you can see 150 rows are there. That is number of entries. 150 number of entries are there, and five are the columns. So first four columns are regarding the sepal length, sepal width, petal length, and petal width. So these are the four input variables. So you can say, okay, let me tell you something about this iris data set. So it was collected by a botanologist. So he was doing some experiment on the flowers. Okay, and he had classified the whole type of flowers on the basis of sepal length, sepal width, petal length, and petal width. Okay, so these are the four variables that he used for classifying the flowers. Okay, so this is that data iris data set, and these are the four inputs. When will you use this? We'll use these four variables as a you can say input variables, and the last one will be your answer, right? So there are three classes, that is setosa, versicolor, okay, and another one. So these are the four your output variables or categories, you can say. So this data set is commonly used when you have some inputs and you want to categorize the data set or new entry into a class, okay, a class or category. So at that time we use a similar kind of data set. So we have okay. Now, as we discussed, we will need whenever we are doing some machine learning, especially the supervised learning. So you will be needing the four inputs, okay, and one output, one or two according to your choice. But generally, what happens is there are one or multiple input variables and respective output variables, output decision or class or category something. Okay, so in here we will use this first four columns as our input variable, and the last one will be output variable. So we need to define those. Okay, so first one in here, that is df.ilog. So first all we will need all the rows, so that is why the colon is here. Okay, then comma, then colon will start all the values, but only the last column is eliminated from assigning the variable. Okay, okay, so this is it. So x will be your input variable, and to define the y variable we know that the output variable is this last column, so that we can use by uh, giving the this command. Okay, df, that is our data set. Okay, so the whole data set has been assigned to this df variable, so that is why df.ilog. From the data set, we are giving the first four columns as input variable and the last one as output. Okay, so that so we'll define it in this way, so that we can further classify or use the data set for machine learning. So this is our input variable and this is our output data. Now normalizing. So what will happen? So first you will need to first you will need to import the library, okay, from sklearn. import the pre-processing function. Okay, and pre-processing there is normalize. So we are normalizing the data set, only the uh, numerical one. Okay, so this is the numerical data, and for this we want to normalize the whole data set. Okay, so that is why we have written here x variable. So that is our numerical variable, and pre-processing dot normalize, that will perform the normalization on the x variable. Okay, so this is normalized x and pre-processing dot normalize. We have assigned this pre-process data set into normalize underscore x. So if we just print this or run this, first we'll need to import the library. So first I'll import the sklearn library. Then second, okay. So you can see that in here you have four. First, notice this square brackets. Okay, so this is first entry. Now then, this one is second entry. Now third entry in this way. Okay, so there are 150 rows and four columns. So in each entry there are four values, right? So first set has four values, and similar way there are 150 sets. So first one will be your 5.1 divided by the maximum value, right? Whatever the maximum value is there. So in here somewhere there will be a one value. Okay, you can find that, but there will be a one value, so that will be your maximum value and minimum value. Minimum, for minimum there will be, I guess, that will be tends to zero, near to zero. Okay, so in this way the whole data set will be normalized, and you can use it further. But okay, we have normalized the data set, but why do we need this, right? So we can, this is also the numerical type of data set that we had used in this, we have in our data set, right? So this was our input, so it is also a numerical value, it is also a numerical value. So anybody can tell me any difference, what is the difference in here? Why do we need the normalization? Easy to compare. Okay. Anybody else? Cut short the range. Okay. Okay, you can say that range is not the problem. Okay, in a way range is also a problem, and you also need to compare that. But if you say it like that, so normalization will be quite critical when you say you have number of data set, number of variables that are in different range. Okay, so say okay, we'll take an example. Let's say there are 500 students, okay, and each and everyone has given a test, but maximum score in each exam was different. Okay, so someone got his score out of 100, someone got his score from 500. Okay, right, in that way. So what will happen, that the guy who has given the exam for 500 marks, so he'll get something, let's say he's getting 150 or something, right? Technically he's failed. Okay, he's getting 150 out of 500, so he's failed, he has failed his exam, right? But the one guy who has given the exam of 100 marks, so he's getting 78, right? He's getting 78 out of 100, and one person is getting 150 out of 500. So what will happen when you will look at the data set, so you will see that the guy who has scored 150, you will understand that he's the one, right? He's getting the highest score. But you see that the difference, he has not even cleared his exams, right? But he is getting more score or more number of marks than another student who has given lesser number, who has given the exam that in which the maximum score was less, right? So in such case, when the range is different, okay, in your data set, when the range is different, you need to normalize that data set so that you can compare, right? Yeah, Vinith was right. We can compare the data set, okay, who has got what, who is getting highest values and who is getting lowest values, okay. And in a way, we are also cutting short the range. So both of you are right. So that is why we'll need the normalization function, right? Okay, so that was about normalization. So anybody has any doubt about this? This is important, right? This will be useful to you in when we move forward, right? First, you need to identify your input and output variable, so that you can do with these two commands, right? This was your whole data set, and you have extracted the input and output variable from this data set. And the normalization is this. So these are the two commands that you will need to use for normalization. Okay, done. Anybody has any doubt? Okay, then we'll move forward. So, okay, this one is for data exploration. In here, we'll see that in a similar way, the data set is imported. Okay, from sklearn, either you can use the sklearn dot data sets and import iris, right? This is also true. There is another method that you can use. So both these two things are same. You can either import the data set directly from the sklearn data set, or you can first import the data sets and then from that data set folder you can import specific data. So we already have imported the data set and we have explored or extracted the input. Okay, so X in here, that is our input command, sorry, input data set, right? If we just plot this data set, then it will look similar to this. Okay, so this is the simple command to plot box plot. Okay, so you know what box plot is because sir has explained it to you earlier. Okay. There is one more thing that you can do. So describe we had seen earlier, right? And there is one more thing that, let's say you have a larger data set and you just want to import the columns. Columns will be your, generally columns will be your variable names, so that you can do with this command. Okay, so okay, so this will be like, so what we have done, we have printed the names of the columns of the data, okay, that we can do with df.columns dot values. Okay, so this you can use to call the your input variable, sorry, not input variable, but the columns or name of the columns in your data set. Okay, so this is it, and then the box plot is done. Okay, let's say just you want to plot a single box plot sorry plot a box plot for a single variable, okay, that you can do with x dot ilog, and then this will be your output, right? So this is your second column, this one second column, because we have given it 1. If you start with 0, then it will give you first one, okay. So this is how you import or plot the box plot in Python. Now next we'll start with MPG dataset. Okay, let's say we want to plot multiple variables, right? In here, what we have done, we had plotted all the variables from the X data set, right? In here, we have retrieved the first column and then plotted it. Okay. Now, what we can do here, we can give the variable names, and only those variables that are called in here, that will be plotted. Okay, so that we can do with this one. Okay, so you can see the difference between the scales, right? In here we can so it will be quite difficult to compare these three variables, right? Or you can see the you can you cannot compare the distribution between these three variables. So in here you can normalize the data set and then compare, right? But these are the altogether in different contexts, MPG and cylinder and all these things. But say you have to compare the MPGs, okay, you have different models of cars or bikes, and you want to compare the MPG for those data sets, right? So for that, well, for those kind of situation, you will need to first normalize the data set, okay, and then compare it with the box plot, so that you can learn the distribution of those data set. This is another command, that is mp.mpg. So it will give you the mpg box plot of mpg variable of the empty data set, right? So this is how you can again call the variable, or call the variable and plot the box plot. So this is another way. In similar way, there is cylinder. You can see the upper whisker is not there. Only one whisker is there. And there is one more thing in plots, that is histograms. In cylinder, there are multiple values, but in here, what I have done, they have taken the you can say beans, right? You know the beans, because there are five uh, beams are here, right? Five beams are there. So whole data set of cylinder is divided into five parts, and according to that, the number of entries or number of frequencies of those you can say cluster is given in here, right? You can specifically uh, define here what number of beans you need. So beans are generally the number of clusters, right? Your whole data set is divided in here into six parts. So first one is 3 to 3.8 something, then 4.4, or 4.6, then up to 5.4 or 5, then 6.3. Then so first cluster is this one, second one is this, third, fourth, fifth, and sixth. Okay, so the whole data set is divided into six parts, and then the frequency is given there, right? You can change the, if you want finer or more accurate distribution of your data set, then you can just divide the number of pins, right? You can, in here now there will be 20 bins. The whole range of data will be such that the whole data set is divided into 20 parts. Okay, so you'll see that the values are missing in here because in those range there are no values, so that is why the data is missing in there. Now next one. Now in here we'll see that we'll just plot a cross tab, right? So it will give you a table in which the number of frequencies, right? It will give you the frequencies. Count means frequency. So for three cylinder, the number of entries are four. For a four cylinder, there are 204 entries, right? If we just change this, because you will see that here three cylinder engine are there, 4, 5, 6, and 8. Now if we just change the variable in here, so you will see that, okay, for this one we can see some changes, because in here there were specific limits, specific entries only, so that is why we couldn't see the change when we change the pin size. Okay, so in here let's say we'll start from beginning. Six pins are there, so you will see that the range will be wider. Okay, and that is why the plot will be in such manner. Now let's say you want some finer results, then you will increase the number of pins so that the range will be decreased and you can see the distribution of your data set. If we just compare this, now, if we just to take a look at this, so you can see that in here only four veins were there, so we couldn't see much. You can see the irregularities. Okay, so in here the irregularity is this one, the number of entries in let's say for 25, around 25 plus minus zero point 0.2 or zero point 0.3, so you can see the number of frequencies is less. But when we see a wider range of distribution, so for that you'll see that for 25 only there is frequencies above 140, but in actual the frequency is lesser, right? So even if we just increase the number of frequencies or number of beans, then you can see the inconsistency in the data set, right? So in here, the, I guess 13 or 14 value is missing. Then the values are getting higher, and so the frequency is quite dissimilar, right, in between these. So, but when the number of beans are lesser, you cannot visualize this. Okay, so that is why it will depend on what type of analysis you are doing, right? So according to your application, you can select the number of beans and analyze your data set. Okay. Now the next one is the number of what was cross table, right? So it will give you the number of counts for each and every value. Now if we just change this, okay, we'll see this for another variable. You'll see multiple values. So 43.4 is, so you won't see a pattern in here. Just you'll see that what, okay, so you first look at this. So first five entries are in simple pattern, but in here you will see that the 43.4. So that is one value in your data set, right? So then that will be next value, that is 44.0. Next value is 44.3. Then next is 44.6, and then 46.6. So it is not in a regular pattern or series. It will just give you the number of value, sorry, number of counts for each and every value. So first mpg values are given there, and the second column is your number of count of those values. So in mpg only single value of 9 mpg is there. Then for 10 mpg there are two number of values are there. Okay, so in this manner. Okay. Now here we have changed the cross tab for origin. So there are in origin only three values are there. So that is why the number of counts are divided in such way. Okay, so in this way you can do your analysis. Now we have seen the box plot, bar plot, sorry, box plot and histogram, right? So that was it for data distribution. Now next there will be data plots. Okay, so similar way, we have imported our data set. Then library is imported of matplotlib.pyplot. Next, we are calling for m only these columns. Okay, md.boxplot, but of these columns only. So you'll see that mpg cylinder and displacement is there. Now, if you just so these things are repeated here. We'll see the categorical data type. Okay, in crosstab, in car name. Okay, so you'll see that for crosstab you can either use the categorical variable or the numerical variable. Okay, so mpg was, I guess mpg was there, that was having multiple values. So this was a numerical type of data set. Okay, yes, mpg was there, right? So it was having numerical values. So there were 129 rows. So these are the 129 unique values in mpg. Now, when we cross step for say car name, so you will see that there will be lesser number of entries. Right? So okay, again there are, I guess, a more number of things are there. Number of car, name of car are different. So you'll see that there are model numbers are also given. So that is why the number of entries, number of rows are much higher. If we just put the car name or brand name, then there will be lesser values. In cylinder 3, 4, 5, 6, 8 cylinders, there are this many number of counts are there. Okay. Now next, displacement for displacement and okay, now here we are seeing a new thing. So until now we had seen the box plot and histogram, right? So we'll see now the scatter plot. So you okay, just I'll plot the data set and then we'll see what scatter plot looks like. So this type of plot is called scatter plot when the values, okay, x-axis and y-axis. Okay, just we'll take a quick review of the things, some of the things that we missed here. So can anybody tell me what the x will what you just need to tell me the x-axis value or data type and y-axis value of data type. Okay. So for all the plots. Okay, so we started from here. So can you tell me whether we can have multiple numerical value on x-axis for box plot or not? Can we have numerical values for box plot or not? Okay, we cannot have. Anybody else? Okay, anybody? One more. Okay, so for box plot we cannot have a numerical value on the x-axis, because what will happen that numerical in the sense continuous values, right? Numerical values are mostly continuous. Generally numerical are considered as continuous values, and there will be categorical variables. Okay, so names and categories or classes are called categorical type of variable. So in here what will happen that you can see the first block, first box plot is for what value, right? We had box plot of x, right? We will take a single variable in here. Okay, this one is perfect. Okay, so you can see the first box plot is for mpg variable, mpg, right? So there is one specific set of data that is uh, defining the mpg uh, distribution or category, right? So let's say there will be pass, distinction and fail students. So you can say that mpg is for pass, cylinder is for uh, fail, and displacement is for distinction students. Okay, so what will happen that if we take the numerical value or continuous value on the x-axis, so that will be your numbers or score. That can be a numeric or continuous type of variable, right? But you cannot have a box plot of continuous variables, because what will happen that in here only three values are there, right? First, second and third. If we take the continuous values in here, so there will be number of box plot for each and every value, right? But for each and every there will be no distribution. Okay, so for mpg we saw that there are values like 9, 10, 10. So for each and every value there will be a box plot, but to have a box plot you need multiple values, right? Then and then you can define the distribution or can see the distribution in that, right? So it is important that you keep that in mind, that box plot can be only plotted for categorical versus categorical versus numerical variable, right? So there will be few categories, and for each and every category there will be number of values, right? So in here if we see in here, so for mpg variable, okay, mpg category, there are multiple values that are lying between 0 and 100. Then there is cylinder type of class, okay, in which the values are lying between 0 and 100 something. And then third category is of displacement, in which the values are lying between 50 to somewhat around 3 500, right? So this is what this type of data you will be needing when you need to draw a box plot. Okay, now next, for histogram, for this kind of box plot, frequency plot, how many variables you will be needing, and whether it should be a numerical type of data set data or a categorical type of data. For box plot or sorry, not for box plot, no, for histogram or frequency plot, what type of variable you will be needing and how many inputs will be there when you need to draw histogram. Just let me know your views. Okay, then for histogram, there will be only one variable you will be needing, and that will be a numerical type of variable. Okay, so for that numerical or continuous variable, there will be multiple values. There will be values that will be repeating itself multiple times. Okay, so for that kind of variable or data, you can draw a box plot. Now, when we go for a scatter plot, you will be also need as aco- you'll be needing two variables on x-axis and y-axis, and both should be numerical type of data or continuous type of data, right? Now you'll see that the values will be plotted in which fashion. So first there will be a value for on x-axis 60 comma, so it will be like say the, vertical axis is your y-axis and horizontal axis is your x-axis. So x comma y values will be plotted on here. So there are values. Say for displacement, it will be on x-axis and mpg will be on your y-axis. Okay, so in that way, uh, first value of displacement and first value of mpg that will be plotted on this space or plane. Okay, so in that way, the box plot will be scatter plot will be generated. Now next way, there is another library. So until now we had seen four libraries. First one is numpy. Okay, then pandas, then matplotlib, and another one was sklearn, right? And this one is also a different library, that is cborn, that is majorly used when you are working on plots. Okay, now you can first import the library, then use the command to plot the data set. Okay, so we'll just do it in a single cell, import the library, and then plot the pair plot. Now you will see that uh, there will be multiple values. So okay, what we have done, we have generated a pair plot for md data set, right? In md data set there were in total 8 variables were there. First being the mpg, cylinder, displacement, horsepower, weight, acceleration, model year, and origin. So here 1 comma 1, 2 comma 2, in this way for each and every variable, there is a box plot, right? Relation between each and every variable is represented in here. So if we go by the diagonal, you will see that this one is for mpg versus mpg. No, it is for mpg versus okay, wrong on this one. So this one is for mpg versus mpg. Then the acceleration, okay, cylinder versus cylinder, horsepower versus horsepower, then displacement versus displacement, and for same variable the box plot is histogram is generated, right? So in here the first diagonal, that is your histogram, right? First diagonal is your histogram, and the rest of the plots are x versus y, right? For mpg versus origin is this one, mpg versus origin, first year, yes, model year, then mpg versus acceleration, and in this way this first column is for mpg variable, and each variable, each plot is having different relationship with different variable. Okay, so that we can study in this single plot by using the SN Seaborn library. Okay, SNS, that is Seaborn library. Now you can color code it also. Now we have used U cylinder. So in here, one variable will be less. That is your cylinder, right? MPG, displacement, horsepower, and only seven variables are here. And the cylinder for cylinder categories are color coded in this way. So all the values for cylinder 3 are given as this color, and the 8 one will be given in this way. Okay, so this is this you can use when you'll be needing some let's say you have a categorical variable and you want to see distribution according to each value of that categorical variable or each category, right? So that you can use with Seaborn library. We'll see a 2 by 2 cross tab in here. So first one will be of origin versus cylinder. So for first origin in cylinder, so there is no three cylinder engine is having no value for origin of 1 and 2, only 3 origin are there. Then in this way, right? For origin and model year, the distribution will be like this. Okay, for cylinder and model year, it will be like this. Okay, so you can see that for each year which cylinder engines were more used, right? You are having the number of entries for. Okay, anybody has doubt up till this? Okay, last one. This will be remove the missing values from your rows. So earlier what we had seen that we were using two operations only. Okay, so first one was for removing not it was not we didn't consider the option of removing the missing values. We either replaced it with mean value or in another way that were given there, that is median or mode. Okay, so we'll see how to remove the variable, remove the row from the variable. So first import these libraries, then we will see that okay, ds is our auto mpg data, so that we can use as md. We are generating a new variable, new data set, that is having okay, that is having we have removed the rows, okay, with the drop na command. Okay, x is 0 is equal to, so that will be your rows. If we put x is equal to 1, then all the columns will be removed that are having missing values. Okay, so this is the meaning of this. First drop na command is used, then x is 0 or 1 according to your choice, and how is equal to any, so that will be all the missing values will be removed. Excuse me. Okay, so okay, we just run this. If we just compare how many values are deleted from the data set. Then first we were having some 398 values of sorry values, not values, rows, number of entries. There were 398 entries in MD dataset, and after the removal of missing values, we have uh, only 392 entries, right? So this is the same as what we have done. MD.shape. Now the last one that we saw first, that we can use the okay, we first use that normalization function, right, to fine tune our distribution of the data, okay, and see the comparison of the variables, right, comparison of the values and variables. So first one we saw the normalization. Now we are looking at standardization. Standardization is also for, okay, so there is a basic difference between normalization and standardization operations. Okay, so in normalization, what we had done, we had divided the each and every value with maximum value, right? Now, what we can do is, in standardization, you will perform the function. You will standardize the distribution, right? So all the values will be changed and converted into a normalized, not normalized, you can say Gaussian distribution, right? For Gaussian distribution, there is function formula, that is z is equal to x minus mu divided by standard deviation, right? So
I think
if
they
we,
don't know the meaning of Gaussian distribution. It's just normal distribution.
okay, then the data is converted into normal distribution, and that way the normalization, standardization is done, right? So the values will be similar, like there were values in between 0 to 1 range, and in standardization also the values will be in between 0 to 1 range. Okay, now x is our iris data set, as we have computed it in the previous commands. Okay, and that we, if we just run this, okay, you will see that these are the values. Okay, so most of the values are between -1, okay, minus, I guess they are going from, okay, we can call this not 0 to 1, sorry, it's my mistake. It will be divided into according to that normal distribution formula, right? Whatever your maximum and minimum z comes, according to that, I'm seeing some values between 6. Okay, so normal, it will be divided into, it will be converted into a normalized distribution, and according to that, the values will be there. It was my mistake to say that it was converted into 0 to 1, but it will be according to the z value, right? Plus and minus z value will be there, and the distribution will be like that. If we just scatter plot it, okay, we cannot scatter plot it. Okay, so this is how we can transform the data set, right, before. So all these things are comes under the pre-processing of the data set, right? For before you start working on your data set, these are the few basic things that you will be needing to fine tune your data set. Okay, pre-process the data set so that some inconsistencies are removed from within the data set, right? You can see the missing values, so that can affect your output. So either you can replace the missing values with values of your choice, or mean value, or something like that, mean mode, or any statistical variable value that you want to replace it with. Okay, and another, we saw the standardization thing. So the normal, it will be divided into normal distribution. Okay, so that is the basic statistical input, you can standardize the input you can take before processing the data set with the machine learning codes. Okay, now the, okay, so second thing, we saw the in the data exploration, in which we saw a few plots. Okay, box plot, then histogram and scatter plot. So these are the basic plots, but it gives you a very rich insight about your data set. Okay, so before you start working on your machine learning algorithms, you will need to look at these things. They perform the pre-processing on your data, and then you will be able to understand what type of data set you are having, and what discrepancies are there in your data set. You can see the cylinder, mpg and displacement. But when you are comparing in here, let's say you are comparing multiple models of cars or bikes, and mpg values are there, right? Then the box plot is a very useful thing. Now the next thing, histogram will give you the values. Okay, so you can see in here that you are having very few entries or sample for 3 cylinder and 5 cylinder engines. Okay, on the basis of this, you can say that for past few years, customers used to prefer, or customer used to buy this 4 cylinder car or 6 cylinder or 8 cylinder cars, right, compared to 3 and 5. So these are the basic plots that can give you a very useful information about your data, right? And the last thing that we saw in here, the pairwise plot, is scatter plot or pairwise plot. So it will give you relationship with each and every variable. So in here you can see that we can see a clear pattern in here, that it is going something like exponential curve. Okay, so mpg value and this one. So if we just look at the fourth column and first row, so mpg versus, that is, horsepower. Okay, so in mpg versus horsepower and mpg versus, what is it, weight. So in here the distribution is something like this. So if we increase the weight of the engine, the mpg is getting low, right? So these are having some inversely proportional values, you can say. If we are increasing the weight of the engine, then mpg values are getting lower. If we are increasing the horsepower of the car, right, then the mpg value is getting lower. So this distribution you can see in this pairwise plot. Okay, so another one thing that we can see from here, observe from here, so that is our horsepower and weight. Okay, so this one is horsepower and this one is weight. So as we increase our weight of the cylinder or engine, if we increase the weight of engine, then horsepower is also increasing, right? So this is the analysis you can observe from this pairwise plot, the relationship you can learn from this. Okay, now this one will give you some more detailed information in here. So if we just look at these three plots that we looked earlier, so that was our horsepower and weight, right? So third one is horsepower in first row, third one is horsepower, this one, and this one is weight. Now if we just look at here, the number of cylinders, right? So the as the color is getting darker, so that the number of cylinders are increasing. So if we look at this, so for higher mpg values, the number of cylinders are lower, right? And as we increase the number of cylinders, it is the mpg value is getting low for mpg versus horsepower plot. So you will get higher horsepower for more number of cylinders, but you will get lower mpg for higher number of cylinders. So if we increase the number of cylinders, then mpg will be lower, so that will be your mileage will be getting decreased or reduced, and horsepower will be increasing, right? Similar way, if we increase the number of cylinders, if we increase the number of cylinders, then mpg is getting lower, and weight is getting higher. Similar way, if we for this one displacement, right, if we increase so this one is for displacement versus horsepower. So this one is for displacement versus horsepower plot. If we increase the number of cylinders, displacement is getting higher and horsepower is getting increased. Okay, so more displacement is for more horsepower. Okay, so that we can that you will be understanding if you are from mechanical background. If we increase the displacement in the cylinder engine, in cylinder, right, So you'd be getting more horsepower. If you decrease the number of cylinders, then it will be inversely proportional, right? So this is how you can learn. Now in here, the distribution is different for multiple cylinders. So first one is, this distribution is for darker, that is one for higher number of cylinders. The middle one is for lower number of cylinder, and this is the minimum cylinder, that will be three, I guess, three number of cylinders. So the distribution will be in this manner. Okay, so weight will be increasing for lesser number of cylinder. So, okay, that will be frequency, your histogram. So frequency will be in this pattern. Cross table you can see to check the number of entries. Let's say in here you are comparing the cells, right? Cells of your number cells as per the number of cylinders and in which year how many cells you did. Okay, so for three cylinder engine, okay, in three cylinder engine the number of cells were almost zero, right? For only 1 or 2 years there were cells. Now if we look at this four cylinder engine, then you will see that number of cells were higher, right, in between 76, 78, and then so if we just look at this, so the number of you can say that number of cylinder four cylinder engines are getting more cells from year 70 to 82. Okay, so the in this way you can in six cylinder engine you will see that the number of cells were higher in between 75 and 78, and then they were getting lower. Okay, for eight cylinder engine there was boom for year 70, 72, 73, and then the cells were getting lower and lower, and almost zero for last 3 years. Okay, so this is how you analyze your data set. So it is not that you will be needing much complex you can say algorithms to analyze your data set. Such simple tools can also be helpful to you in understanding your data set. Okay, so this was for today. We did something. Sir, can we pause?
Amit, you can give some assignments to them for practice. I mean,
Okay, yes sir,
during this
I
time.
forgot. I have okay, so for
Okay.
today's assignment, okay, I so these commands are given in here. So what type of, okay, in here I'll write the assignments here. Yeah, just
Regression we'll be doing next week. I
yes
mean,
sir.
tomorrow.
Yes sir. Yes, sir.
Okay. Okay.
For today's assignment, you can import the iris dataset from the library. First, this one you will have to do, and then you need to perform three functions. Okay, for imputing the dataset, first you can replace the missing values with mean value, right? Mean value of that variable. I'll write down the assignment in your classroom. Okay, but I'll just explaining it to you what you will need to do. So first you will impute the data set missing values with mean value of your variable. Second, you will normalize the data set and replace the variable. Replace the missing values. Then you will standardize your data set and then replace the values, missing values. Okay, so first you for missing values you need to do three things: missing values, and okay, and once the missing values are dealt with, then you will need to perform the pair plot analysis. Okay, the histogram and box plot are also important, but they are easy ones. So this is included in here. The box plot is also box plot analysis you can do from here. So from SNS library, you need to perform the pair plot for all the variables of iris dataset, right? And on the basis of your output, you will need to analyze the results. Okay, so these are the two things you will need to do in your today's assignment. First, impute the missing values with mean value. Okay, normalize the data set, and then impute the missing value with mean value. Then standardize your data set, and then impute the missing value with mean values. Okay, that will be your first part. And second part, you will need to analyze your all the variables by using the SNS library. Okay, so these are the two things that you need to do for your as your assignment, today's assignment. Okay, I'll write it down and upload on your classroom.